Welcome back to my first video. Today, we will discuss about static and dynamic binding. Static and dynamic binding. Static and dynamic binding. I am Albert Dayasan and I am a computer science student. And today, we will talk about data binding. So what is data binding? Data binding is the association of the method call to the method name. We have two types of data binding, which we call static and dynamic binding. So, what is static binding? Static binding is also called early binding and happens at compile time, meaning when there is no ambiguity in your method calls, then the compiler already knows what method to execute at runtime. Private, static, and final methods are examples of static binding, and also overloading is also an example of static binding. On the other hand, dynamic binding is also called late binding because it happens at runtime. It usually happens when there is ambiguity in your method calls. Overriding is the usual example of dynamic binding. So, let's see some examples of static and dynamic binding. First, let us create a Java class. Let's call our Java class human. So after we created our main class, let us create some methods. So let's say our first method is a public, static, and a void. Let's call this eat. And our first method has arguments, which is string food. Then we will create a variable of string type. Let's call this eat, and it is equals to the food argument that we have put. And then we will create some print lines here. This is the print line. Let's say our human here is saying I have error. I am eating. And let's concatenate our, let's call this eat. And let's concatenate our variable here eating. So let's say we want to create another method here. But in this method, we will pass two arguments. So let's make this method public and static and void so it won't return anything. Let's call this method meal. Just what I've said, in this method we will pass two arguments. The first argument will be the food, just like the other one, and the next one will be drinks. Let's call it drink. After we create our second method, let's create some print lines here so we can show later what our arguments have passed. So let's say our human here is saying that his dinner, my dinner is, let's concatenate the food and the drinks. Oops. Let's say that's what we want to do. So in our main method, we will create our food and drinks variables. So let's make string food drinks. Then the value for food variable will be, let's say, Bake Mac. And in our drinks is tea, iced tea, because I love iced tea. T. Yeah. So after instantiating our variables here, what the value of these variables will be passed to our methods that call them. So to execute our methods, let us make a method call, and let us use a class reference. So it's human and eat, but we will pass on our food variable. After that, let's create for the meal method. So our second meal food, food and drinks. So let's see what will happen. As you can see, our first method is called, and our second method is also called and executed. So where is the static binding here? Static binding happened when there is no ambiguity in our method calls and our method associations to the method definition. So here, when we call each method, the compiler at compile time, it already knows what to execute. It already knows to execute this method, these lines of code. And in our second method call, it already knows that it will execute this method call, this method definition. That is what static binding is. When there is no ambiguity with the method call and the method definition. As what I have said earlier, static, private, and final methods are examples of static binding. But what if our method samples here are not static? So let's get rid of this, and our methods have the same name. So our first method, we will rename it a meal. So they are the same now. Since our methods are now non-static, we are now obliged to create a class object. So let's try to create some human object here of human type. Then let's call this obj new. So we can instantiate it, and the object type is of human. So our class reference here, we will replace it with our object of our class object. And let's replace this with me. So let's see what will happen here. So as you can see here, we also got the same results as earlier when we have static methods and different names. What happened here is overloading. Overloading happens when we have two or more methods that have the same name but have different parameters. So they have different method signatures. When we say method signatures, this is the method name and its parameters. So this whole line here is a method signature. And since our first call here has only one parameter, at compile time, it already knows what to execute. So it knows to execute this meal method that have only one parameter. And our second call, it already knows to call our second meal method that have two parameters. So that's it for static binding. Let's see some samples of dynamic binding. First, we will create a Java class, and this class we will name this shape. So in this particular example, we will have inheritance here. So after we have created another Java class and its main method, let's try to create here a method. So in this method, we will have a print line here, and let's have no drawing, no shape. After this, for us to demonstrate dynamic binding, we'll try to create a subclass for the shape class that we already created. So let's create another Java class. Let's call this Rhombus. Our Rhombus will extend the shape class. Extends shape. Let me just try to multi-window this so you can see clearly what is happening. So our Rhombus class will have another method of the same name. So we will create another public void draw here. Draw. So in this, we will create another print line. And in this print line, he will say, our Rhombus class will say, I am Rhombus. Let's say we have another class that is a subclass of the shape class. So let's try to create another class. This would be Pentagon. So in this Pentagon, this is another subclass for the shape class that we have. So this will extend the shape class. And another draw method. And another print line. So in this particular class, let's say it is like a Rhombus that it says I am Pentagon. So we will go back to our main class and let's see what will happen. Let us try to create an object of shape type. So shape object and instantiate it shape. So after this, let us try to call each methods in each subclasses and this superclass. So let's say obj dot draw, and let's override our object type new Rhombus. We'll explain it later what I was doing here. And another object call, and let us override again our object type. So what I have done here is I created an object which we called obj of reference shape, and our first instantiation here is of shape type. So in this method call, we are expecting to have this print line. We are expecting that this method here will be executed. In the second one, the object type of our object is changed to Rhombus class. So we are expecting in this second method call for draw to execute this one, and the same with this one. We change again the reference of obj to Pentagon, and we expect in this method call that it will call this method here. So let's try to run this one. You see, what happened here is at compile time, because our obj object is of shape type, every method call here, every obj draw is pointing to this method at compile time. Since this is a dynamic binding sample, dynamic binding refers to the object type, not on the type reference. So our obj object is of shape type, and in this first instantiation, it is pointing to the shape class. So in this first method call, it executed the draw method in the shape class. And since we overrode our obj class and pointed it to the rhombus class, in our second method call, it executed the draw method in the rhombus class. And the same with the pentagon class, we overrode again our obj method, our obj object, and pointed it again to pentagon. So in our third method call, it will execute now the draw method in the pentagon. So the main difference between static and dynamic binding is static binding happens compile time when there is no ambiguity in your method calls to your method definitions, and when you have private, final, and static methods. And on the other hand, dynamic binding happens when there is ambiguity in your method calls to your method definitions, when at compile time, it does not know which methods to call at runtime. And the second difference is static binding uses type reference for compiling, and in dynamic binding, it uses the type of the object, not the type of reference that static binding uses. In dynamic binding, it uses the type of the object it is pointing to. Just like in this example, we have the same object, but it is now pointing on the rhombus class. So, this is it for this lesson. I hope you learned something, and see you soon. Peace out. Wear masks.